In this video, we'll be continuing to work with the sine and cosine sum and difference identities. So this next example specifically asks, write each expression in terms of a single trigonometric function. So I've got this obnoxious looking thing such that it's the sine of 5x cosine of 3x, then there's a multiplication sign between them, minus cosine of 5x sine of 3x. And my goal is to write this as a single trig function. Now this seems, again, quite difficult and tricky to do if we don't have our identities understood or at least semi-memorized. So I've got the identity sitting here in front of me, and I've worked with these things so much that I know that the sine of 5x cosine of 3x minus the cosine of 5x sine of 3x, the fact that I'm seeing 5x and 3x repeating themselves, and I see that sines and cosines are all across this, that in some way this should translate into one of these identities up here. Now, because again it's sine and cosine alternating, I know that I'm working with sine or sine, again plus or minus. I also know that because this is a minus sign, I should really be working with the negative case, because the sine function, again using the sum and difference identities, remain constant. The sign remains constant throughout these problems. Now, if I look very closely here, I have the sine of 5x cosine of 3x, and you'll notice here I have the sine of x cosine of y. Minus, minus. Then I have the cosine of x, cosine of 5x, and then sine of y, sine of 3x. Which really implies that maybe this thing should be equivalent to the sine of x minus y. But if I replace all of the x's in here, I'm going to go ahead and circle them, all of my x's in here, which are the same x's in the identity, sine and then cosine. If I replace all those x's with 5x, well then that first piece should be 5x. And then if all my cosines here, I'm going to go ahead and put those things in boxes. You'll notice that the 3x here and the 3x here should both be y's. Then you'll notice that this is sine x really minus 3x. And I can simplify this trig function from all of this extra stuff into the sine of simply, well, again, remember, I can simplify the inside of a trig function separately. That means that 5x minus 3x is simply 2x. And this entire obnoxious looking thing just becomes the sine of 2x. Again, the goal of these identities is to help us manipulate and simplify what we're looking at. So it's important for us to be able to recognize when the identity might show up. Again, I happen to see it here, so then I will use it here. The next one, I'm looking at 5b as the tangent of 4 alpha plus the tangent of alpha divided by 1 minus the tangent of 4 alpha tangent of alpha. Now, what's important to notice on this one is the importance of that there are other sum and difference identities. Now, I don't have all of them written here, but there is a tangent set of identities. And that tangent set of identities, at least for the one that we're going to work with, is the tangent of x plus y happens to be equal to the tangent of x plus the tangent of y divided by 1 minus the tangent of x tangent of y. Now there is again a difference identity in place of this, where this is going to be a minus sign and this is going to be a plus sign. Both of these identities are on your identity sheet, so in case you need them, they are there. But you'll notice here that as I'm looking at this, I have the tangent of 4x while I have the tangent of x, and the tangent of 4 alpha, and then I have the tangent of alpha. Noticing the x is 4 alpha and y is alpha, I can very clearly transition this to simply be the tangent of my x is supposed to be 4 alpha, so 4 alpha, plus, and then my y is supposed to be just 1 alpha, so alpha. And then again, one more time, just like I did up here, inside this trig function I can simplify. So the tangent of 4 alpha plus alpha is simply 5 alpha, and that completes that particular problem.